Imagine an organization facing a massive, critical supply chain problem. To solve it, they build a mathematical model of absolute mechanical precision. The data fed into this system is entirely clean. Every algorithm has been vetted, tested, and rigorously verified to ensure an error-free analysis. Yet, when the project is finished, this perfect model fails to alter a single business decision. This paradox happens frequently across industries. A team can produce a completely accurate, perfectly sound quantitative analysis and still generate zero real-world impact. In the field of analytics, mathematical perfection does not guarantee operational success. This diagram shows the CRISP DM model, the industry standard for mapping out a data mining project. It presents a sterile theoretical sequence of steps, from business understanding straight down through deployment. But in practice, this rigid process relies entirely on vulnerable handoffs between different people. It functions less like a clinical methodology and more like a human relay race. The project has to pass seamlessly from the executive to the data engineer to the analyst and finally to the manager who makes the call. Projects rarely fail during the actual data crunching. They die in the empty spaces between those individuals. The first critical drop point occurs at the very beginning of the relay. A business executive senses a symptom, like declining market share, and attempts to pass that problem to an analyst. If the executive gives a vague directive, the analyst, who often lacks the broader domain context, has to guess what the real issue is. They might build an elegant solution that optimizes for the completely wrong underlying variable. This initial error ripples outward. Data engineers end up spending massive amounts of time extracting, cleaning, and curating extensive datasets that don't address the actual business need. Ultimately, a misaligned first handoff guarantees project failure. The team will be routed perfectly to the wrong answer, regardless of how robust the subsequent math turns out to be. The second major drop point sits at the other end of the chain, where the analyst must pass their findings back to the decision maker. Often, an analyst builds a brilliant quantitative model, but instead of translating the results for management, they simply throw the raw numbers over the wall. Management may not share the analyst's quantitative training. Faced with a complex, opaque model, a manager will typically distrust the math and refuse to integrate it into their workflow. This flowchart illustrates how raw data is processed into information and eventually into wisdom. The final step, converting information into actionable knowledge, is a threshold that must be crossed for the process to actually matter. If an analysis cannot be clearly communicated and sold to management, it is functionally identical to an analysis that was never performed. Even if the model is sold and a policy is enacted, there is one final, widely neglected handoff: measuring the actual outcome. Once a decision is made, ownership of the project often vanishes. The team moves on, leaving the true real-world impact of the model completely untracked. When organizations fail to measure these outcomes, they lose the ability to verify their work. They cannot learn from their mistakes, adapt to new conditions, or update the foundational assumptions they used in the first place. Without measurement, the analytical process becomes a dead end, rather than a compounding strategic asset for the company. We tend to think of analytics as a straight line from a question to a decision, but that linear structure is a trap. This business performance management diagram shows that true analytics requires a closed loop. Final decisions feed directly back into the next problem's intelligence phase. Organizations strategize and plan, but must also monitor outcomes and adjust future plans. The process continuously feeds back on itself. It is worth noting that in smaller businesses, these distinct roles, executive, analyst, engineer, and manager, might all be performed by a single employee. Yet, even if the physical handoffs occur entirely inside one person's head, the functional transitions still exist. It is just as easy for a solo analyst to optimize for the wrong variable or fail to track their own outcomes. Mastering this closed loop requires securing every single transition point, regardless of organizational size or the structure of the team. This brings us back to the mathematically perfect, completely useless model we started with. That specific model died in the empty space between insight and decision. The analysis was flawless, but no one owned the exchange to the decision maker. Analytics is, above all else, a relay race. The math only matters if it crosses the finish line. These projects fail at the baton pass, making the human element the ultimate variable.